Hi and welcome to Unit 2 Topic 3 Video 3, where we're going to continue our work on matrix arithmetic. This is the final one of our more simple concept videos, and then we'll move into matrix multiplication, which really isn't that hard, but it's the one new thing. So let's have a look at our last little bit of arithmetic, and this is just picking up on a couple of little nuances. So solving matrix equations, and also how to deal with the individuality of cells. So note here in black at the top that we can do some matrix rearranging by considering some basic matrix arithmetic in equation form. Negative matrix B is equal to negative 1 times matrix B. Seems obvious, but it's a really helpful thing to work with. Negative 1 is just scalar. Remember, scalar is just a number. A plus 0, so the 0 matrix, is equal to A, as you'd expect. And A plus negative A is equal to 0, as you'd expect. And so therefore A plus negative 1 times A is equal to 0. So this is all what you would expect to see, but it's always good to note them down mathematically. So what we're going to do in example 3 is we're going to solve this equation, 2p minus x equals q. Now P is a 2 by 3 matrix and Q is a 2 by 3 matrix, so that works. It also means that X will be a 2 by 3 matrix. So this is what I'm going to do. I'm going to write this down as 2p minus x equals q. So therefore minus x equals q minus 2p. And then remember, minus x is minus 1 times x equals q minus 2p. And to get rid of that minus 1, I can divide by minus 1, or I can multiply by minus 1 to cancel it out. But I ultimately end up with x equals negative q plus 2p. Or 2p minus q. So to work out my value of x, I'm going to calculate 2p minus q. Now hopefully you'll recognise here it's actually a lot easier for us to do this rearranging before we substitute the matrices in. So that's an important rule to take on board as well. So now I'm going to substitute the matrices in. 2 times p, which is 3, negative 9, 1, 2, 6, 4, and then minus q, which is 0, 1, 1, negative 1, negative 1, 0, is going to be my x value. So it's 2 times 3 is 6, negative 18, 2, 4, 12, 8, minus 0, 1, 1, negative 1, negative 1, 0. And then my final answer is 6 minus 0 is 6, negative 18 minus 1, negative 19, 2 minus 1 is 1, 4 minus negative 1 is 5, 13 and 8. And that's the value of x to solve that equation. Hope you can see how that matrix equations works. And our second example for this video is to do with the individuality of cells. So we're going to solve for A, B, C and D. Now what's important here is that we have this uniqueness of cells. A, which is probably one of the easy ones, A is there, and it's related to the 4 and the 10, but it's not related to any other values here. So I'm going to start by simplifying this particular equation into a 2 by 2 matrix equals a 2 by 2 matrix. And then I'll be able to solve for D, A, B and C. So when I simplify this, so I get 10 minus 3 times 4 is negative 2. And then I get d squared minus 3d, whatever that is. And then I get 4b minus 9. And then I get 1 minus 3. And that's equal to A, 10, B and 2c. So starting with yellow, what this means is that negative 2 is equal to A. So I get up here A equals negative 2. And this is my yellow one. And then in green I get d squared minus 3d is equal to 10. So this is my tricky one. So I'll just denote that this is the green one, and then we'll go ahead and solve it. So I get d squared minus 3d minus 10 equals 0, which means that d minus 5 and d plus 2 equals 0, which means that d can equal 5 or negative 2. There's a quadratic solution by factorising. If you're unsure of that, you should definitely go back and reaffirm your understanding. So d could be two values. It's quadratic, that's okay. Then I get 4b minus 9 equals b. So that is 4b minus 9 equals b, which means that 3b minus 9 equals b, which means that 3b equals 3b minus 9 equals 0, which means that 3b equals 9 and b equals 3. So we'll just highlight that's the new spot there. And then of course we've got our c, which is going back to being a bit easier again, which is nice. So 2c equals negative 2, 2c equals negative 2, c equals negative 1. And there we go. So I'll highlight all of our solutions, and you can see where they relate to in terms of our cells. Okay, so there is the end of our basic matrix arithmetic with all our special matrix definitions and some nuanced cases like this one, for example. And in our next video, video 4, we're going to move on and talk about matrix multiplication. All the best.